G'day guys, Mac with the Outer Circle, and today we're reviewing the Ender 3 Max Neo. Now, disclaimer straight at the start of the episode. This printer was sent out to me as a review copy by Creality. I did not purchase it for myself. However, as with all of my reviews on this channel, it'll be open and honest. I've had many Creality printers over the years. My first printer I ever bought was actually an Ender 3 Pro, believe it or not. I also had a Ender 5, Ender 6, CR10 V2, and a few others along the way. And the latest one that I've put together is the Ender 3 Max Neo. So, first things first, putting it together out of the box. Very, very simple. It pretty much came fully assembled. All you had to do was put 4 bolts into the upper arms of it and plug in the cables and attach the filament holder to the side. That's it. All the tools that it needed came in little Ziploc bags, and it actually provides a little drawer on the front of it which you can put your tools into, which is nice. So, what is this printer for? That's probably the first thing we need to get into. Well, this printer, for me, is a terrain printer. I like the Ender 3. In fact, the Ender 3 Pro, which is this printer here, was the very first 3D printer that I bought. And it was good for what I needed to do. And I have printed thousands of hours now of items on this printer. I did all of the terrain, for example, for my event was done on this and my CR10 V2. So I did an entire event's worth of tables over the course of last year, and I've kept going this year making more and more terrain and products. It's been quite a good printer. However, $236 US versus $369 US. Is the price difference between an Ender 3 Pro, which I would say is your bare minimum starting point, and an Ender 3 Max Neo worth it? That's a tough one to quantify because everyone's needs are going to be different, but there's two things that I really like about the Max Neo. The first is it has an insulated print bed. That means it retains heat for longer and it's more even the amount of temperature through the bed. That means that you're going to have a lot better time trying to get your prints to stick to the bed top. In this case, it's a glass called, I think it's carborundum. Now, another thing it has is obviously that carborundum glass is better than the sort of flexible build plate that's provided on the Ender 3 Pro. The Ender 3 Pro also has a much smaller bed, hence why it's called the Ender 3 Max Neo. You can print larger items for yourself on it. Now, the Ender 3 Pro is what I consider a starting point printer. So if the Max Neo is an upgrade on it, where does it sit? Well, I think it's a printer that is really good for a person who's getting into 3D printing, especially for terrain purposes. That's what filament printers are really good at. And the larger build volume means that you can do more with it. It also has the BL Touch built in. So for those who are wondering, the BL Touch has to do with the bed leveling, hence BL. What it's doing is it's going around and touching multiple points on the plate to make sure that the distance between the nozzle and the plate is consistent as it's actually moving around and creating your print. If it's not consistent, you'll get things like the filament won't stick, or maybe the tip of the nozzle will just drive itself into the glass. Either way, that's not a great situation to end up in. Now, the BL Touch is a good system, however, it's not a perfect system. And this was one of the major problems I found with it, was you really do have to go around and make sure that you set the leveling as close as you can manually first. This was a big downside of the printer. It was good, but it wasn't good enough to make up for more than, say, 0.5 millimeter, if that even, of difference in height from one point in the plate to another. You also have to change the Z offset. So, as you'll see later on, Z offset is the height between the tip of the nozzle and the bed itself. You want to be down to about 0.1, maybe 0.2 millimeters above the bed. And when it first zeroes in the height, you're actually going to be over 2 millimeters, maybe even 3 millimeters. Again, depends from printer to printer. Sitting off the bed. And if you try and print at that height, you will just get failure after failure. So unfortunately, a little bit of thought has to go into actually utilizing this printer versus the Ender 3 Pro. On the old Ender 3 Pro, you simply stick a piece of paper in there, run the dials until the nozzle sits at a nice height in those bits of paper, and you're good to go, essentially. Now, downside is the more you play with the Ender 3 Pro and you keep pulling the build plate on and off and on and off, and small amounts of error creep in, especially because it's only single axis stabilized on the Z axis. And what do I mean by this? Well, if you were to look at this side on, there is a screw that runs up the side of the printer here, and it runs beside the extruder at the back. Well, that screw there, unfortunately for our Ender 3 Pro, is a single screw, which means if there is any deviation from side to side as it goes up, you can kind of get this weird Z-axis misalignment. On the Max Neo, provided that the machine is relatively well looked after by the operator, this isn't an issue, because that dual Z axis, what it has is it has two motors on the side, and it's running two screws. As you can see here, the screw runs top to bottom all along the side of the machine here. That means your Z axis, it stays pretty damn parallel. That's great. User interface is also better. So lots of pros coming in for this machine. So is it worth the extra money? I'd say yes, actually. I would happily buy one of these in this day and age as a starting printer if I was getting into printing, say, terrain, basic 3D models for myself. Now, you can print lots of stuff on this. You can print different materials on this, sure. But obviously, with this channel and the things we focus on, we're mainly looking at wargaming, and I find personally that terrain is the biggest thing you can print. Now, you can print lots of other stuff like storage boxes, little tubs. You can print bases. I've printed a lot of bases recently for Warhammer Fantasy, square bases, on this printer. It's been fantastic at it. But they have an obvious hard cap on how much detail you can get out of them. And as you'll see in the printing that we do, I actually don't run them up to maximum detail. I usually sit around the 0.2mm layer height, which is a lot if you compare to, say, a resin printer. It's about 10 times what a resin printer is running at generally. And you can go down to, say, 0.1, for example, and get a very crisp, excellent 3D print. But I didn't do that, because you don't need to do that on terrain. And as you'll see, the quality of the terrain we produced was excellent. So the printer did its job. Now, what issues did I fall into? Well, biggest issue with this printer, and one of the biggest failings for it, is the extruder. This type of extruder is very simple, very cheap. If you look at it here, it's a simple lever system, and it relies on a gear and an idler, essentially an idler pulley. And that little gear is constantly being pressed via a spring, or the idler is being pressed against the filament and then against the gear tooth by a spring. That gear slips a lot, and it can lead to what we call under extrusion, especially if there's any contamination inside the nozzle of the printer. This was a problem on the Ender 3 Pro, and on the Ender 3 Pro, this part was actually made out of plastic, not aluminium. So, whilst it's definitely an improvement to be an aluminium, because it is now a lot more sturdy and it won't just break on you. In fact, these are renowned for breaking in plastic. In a previous video I did on filament 3D printing, that exactly did happen on my Ender 3 Pro. It is sturdy and reliable, but the actual feeding is not reliable enough. I found that I had issues with under extrusion, so the plastic wasn't being pulled through at the correct rate for the print speed on the printer. This meant that you end up with a really thin, stringy type of film, and it didn't look very good in the end. When you start seeing that, I immediately stop these prints when it starts to happen, because you're just setting yourself up for failure later in the print. Why spend 15, 16 hours printing something if it's going to be a fail anyway? It's not worth it. But this could easily be fixed by putting a dual gear extruder into this. So that would be one of the major things. If they had a Max Neo V2, for example, I would either like a direct drive dual gear extruder or a dual gear extruder straight from the get-go. Another thing you'll see is just to the right of this frame, that's a filament runout sensor. So this printer is smart enough, and I did test it out, that if you run the filament through, it will actually sense that, oh, I'm out of material, and stop the print at that position. great. However, because the printer isn't the highest end model, it doesn't necessarily pick up from where it left off with the cleanest of lines. Unfortunately, you get a little bit of, I'll call it dribble, but it's excessive extrusion that is coming out of the nozzle while it's heating back up after you've changed out the filament. And that little knob or blob can either catch on things, or it can even knock your print clean off the bed if you're unlucky. That's something to keep aware of with these printers. Another little thing that I noticed was the Z-axis acceleration straight out of the gate was not great. The axis acceleration is when you get to the corner of an item that you're printing and it needs to move around that corner. What's happening is it essentially is traveling a shorter distance in the same time frame but sending just as much material out. So your corner ends up being a little bit blobby, and you'll again see this later on when I show you examples of prints. And instead of having a nice sharp corner, you have a slightly rounded off corner which has a pronounced lip to it. Doesn't by any stretch of the imagination ruin the terrain, but it's something to keep in the back of your mind that a lot of these printers straight out of the gate, no matter who the manufacturer is, all do this. But these were things I encountered in my test. Now, the biggest fault of all, people are going to want to know, and it was a major fault for me straight out of the gate, and that was there is a small sensor, and that little sensor is located right where that QR code is on the top left of the printer. That sensor there is an X-axis sensor, and it is telling you telling the printer when the print head is as far to the left as it's able to travel on the X-axis, and setting the zeroing position. On my printer, it was missing the lever that triggers the sensor. There was just a little red button and no silver stainless steel spring that should be depressing the button. This meant that when I first powered up the printer, I didn't even think to look if that part was installed correctly. So I hit 0 on the printer and the head flew to the side, and then a horrible grinding noise of gears trying to take it through the sensor on the left hand side took place. That was a pretty nasty experience, and I was easily able to repair that by printing out a small little block of plastic and attaching it to the side of the extruder, and that new piece of plastic actually does the triggering for me and actually has worked perfectly, flawless system. But shouldn't have had to do that in the first place. When you are sent something for a review, it is really important in my mind to send something out that is fault-free when it comes to the basic construction of it. Shouldn't be missing screws, shouldn't be missing parts. And it wasn't in the box or anything like that. I did double check to see if maybe it had fallen off in transit. No, it was just outright missing that part. So that is concerning to me that happened. Otherwise, though, performance of the printer has been exemplary. The build quality, apart from that one thing, has been fantastic, and it has performed from the get-go and consistently. The only failed prints I had was due to the under extrusion, and I was able to dial up the heats on the printer. Just simple 10 to 15 degrees on the nozzle was more than enough to overcome that. I'm guessing that was down to the type of material used. I was using a spool of this CR 1.75 PLA in the rainbow, and I also have another printer that I'm reviewing at the same time, which is using this particular filament. This particular filament I found printed much better at the same temperatures as this filament in a basically identical nozzle setup. So yeah, little word of advice there. If you are running this material, consider actually running it at a slightly hotter temperature if you're going to be printing with it, and consequently you might want to increase the speed a little bit on the printer, just so it doesn't over extrude because the plastic is melting a little faster than you would expect it to. Anyway, that's enough of this. Let's get into the actual printing itself, so how we set it up, and what we actually do from there. Alright, just like on other printers now, we're going to do some slicing. This is going to be very easy, so we pick from the list of printers that I currently have installed in this slicer. In this case, obviously the Ender 3 Max Neo. I'm going to take a file from the side here and just drag it in. You'll often find that if you keep your files in your downloads, they don't like being dragged into slicers. So for the one I'm working on at the time, you've got to move it onto your hard drive. out of your downloads or temp folders, or in this case, I just like to put it directly onto the desktop background. I'll then put it back into its appropriate file or just delete it. So when it comes to the slicing options, I've just got the standard quality one here. There's all sorts of custom, super dynamic, super quality, low quality, all that kind of thing available to you. Exactly the kind of things you would expect. But you can pick any quality you like and you can modify it from there. You can pick your travel speeds, retraction distances, retraction speeds, the actual speed of the printer itself as it's moving along. So generally infill speeds are going to be faster than outer wall speeds, for example, which you can see here with infill speed at 50 and outer wall speed at 25. That's because your outer wall needs to be a really strong bond and you're going for a thicker deposit of material. Versus your infill, which is going to be a little reinforcement on the inside. That doesn't need to be super thick, super accurate, because it's just supporting the rough shape of the item. You've also got things like support, so you can pick a different support here by generating support, and you can pick where you're going to put it, what type of supports it's going to be. I don't want a support because this particular item doesn't need it at all. Build plate adhesion, so brim, skirt, raft. These different ones are for different purposes. So for example, a raft is really good for an item you want to be able to easily remove from the raft. It is a small, couple mil thick printed bed, essentially, that you can place the item onto. A skirt is essentially just a line of filament that's actually around the printed item, and a brim is like an extension of the basic footprint of the item, just to get more surface contact. But again, this particular item doesn't need any of that sort of thing. You also have things like mesh fixes, different special modes, experimental modes, but infill, of course. I'm using gyroid at the moment, but there's quite a lot of good ones. Cubic, concentric, zigzag, cross, triangle, trihexagon. All these different patterns, they're all just different shapes. Okay, none of them are superior to one another. I'm just picking gyroid because I think it's a really easy to print type of infill, because rather than crisscrossing back and forth across the item, it just prints a sort of squiggly line from one end to the other, and I find that actually prints faster for my needs. So anyway, once you've picked all the settings you want, and you've picked the speed you want, and in this instance we're printing at a 0.2mm layer height. Now, super quality down to 0.12 it's going to be high quality, yes. You can get some spectacular quality out of a printer running at that height, but you have to look at things like, are you going to change your nozzle tip diameter? Are you going to change the particular filament you're working with? You're going to have to play with the speeds, the feeds, and the material itself may need to be changed. So all things to keep in mind when you're working with it. Now, for the actual slicing itself, well, slice. Obviously, there's all the normal functions on the side here, which we should probably talk about. So you can change where the item sits on the axis. This is good if you want to just slice part of an item, for example. So lower it down through the mesh, and you don't even have to make the item in, say, a Blender, for example, or a Fusion 360, and re-slice it down to a smaller size and make a new STL. No, you can just lower it down through the mesh. You're also able to obviously rotate these things around on the bed. So you can do that either through clicking and dragging, like so. Or you can go with these resets, flats, snap rotations, that kind of thing. You can also mirror the item, which doesn't really affect us. And of course, there's things like scaling, can make it bigger, smaller, all that kind of thing with this one over here, which again, you can click and drag, or you can change up things by percentile, and uniform scaling. Now, uniform scaling means that when you click and drag on one axis, they all move at the same time. If you flick that off, it allows you to stretch or modify an axis. So I prefer uniform scaling. And now I can uniform scale it in its weird stretched axis. But we're not going to do that. We just want a simple ZM column. I've already got my settings how I like them. Slightly thicker wall with a 10% infill. It's heaps for what we're using. We just don't want to waste as much PLA. And this is slow printing right now. because I've really dialed back the settings to very, very similar to stock standard. Because that's what most people are going to get when they come out of the box. Yes, you can play with them, and I highly encourage people to play with the settings, but straight out of the box of these printers, you really just want to learn how they work first before you go playing with things. People who are already into printers and already understand how to use them, obviously they can just experiment. Now I simply can save to my removable device and eject the SD card from the printer. Now that I've ejected the SD card from the computer, I can go and plug it into the printer and we can actually begin to print the item. Alright, so when we go to actually run this printer, you'll see that this screen here, it's not actually a touch screen, it's a dial fed screen. So you actually have to rotate the dial in order to move from one area to another and depress the dial in order to actually hit the functions. I usually go in, preheat my PLA, go back and then select the item that I want to print. This means that it doesn't just heat up the bed and then the nozzle, as these printers often do. They often don't heat up simultaneously because it draws more power. Well, I like to preheat everything at once, so it's not sitting there idle while it's waiting for one part or the other to print and heat up on the printer, I should say. So going in and actually starting the print, you have to go into Tune and make sure that your Z offset is set to the correct height. It actually does remember this, so once you've set it once and you're happy with it, it will retain that information, and during the print at any point, you can go back into Tune, change heat, change print height. It'll also go in as you're actually setting up a print to start, and it will zero itself. This will be a combination of zeroing X-axis, Y-axis, and of course Z-axis. Now on the Z-axis zero, it doesn't rely on a traditional sensor. It's using that BL Touch, which will light up as a purple or a lilac color and is generally navy blue, and you'll see it flash purple as it makes a particular setting. Then it will go along and it will run a single bead of filament. So this is the extruder. Essentially it's warmed up and it's just getting rid of anything like air, for example, or contaminants that might be in the nozzle before it starts the proper print. Then it's actually moving over to the print area. So once it goes into the print area, it will either lay down a brim or a raft if you've selected, say, a support, or it could lay down a skirt, for example, or in this case, it's going to go straight into the actual print itself. So I've set the wall thickness here for, I believe, 2mm, so it's running enough material to cover 2mm of thickness. It will do this on every layer of height to the end of the print. It's going to go in and it's going to lay down this outline, and then it's going to do what we call infills. But before it can do that, it needs to run several layers of base layer. Now, what is the base layer? Well, this is essentially the shell or the outer wall of this printer when we first set up the print. If you don't do this, whatever infill or internals you have on the part will be exposed to the open air once you pull it off the print bed, and we can't have this. So it's going to run several of these layers over time in order to actually print out the product that we're desiring. As you can see, during operation, it's nice, it's smooth, there's no weird noises coming from it, or you won't hear them with my voiceover going through the video, and the BL Touch is this lovely sort of bluish purple colour, which I think looks pretty neat. And as you can see, it's actually getting through very, very quickly printing out this part. So the base layers take a long time because just a lot of movement back and forth in the same slow axis. When it actually gets into the vertical movement, it will then go very quickly through the print. It will only take a few hours. And this is with basic print settings. We're not even looking for advanced print settings here, going into Cura or anything else like that. As you saw, this is all being done with the basic settings of the Creality slicer, which is basically a Cura clone. You can get a bit of a feel as well for a correct first layer right now. So you can see consistent lines from one side to the other, same sort of color, all touching, no gaps, no bed exposed through the base of it. If you're not seeing that, you need to be concerned. Think back to the start of the episode when I was talking about the under extrusion and how big of a problem that was. Well, here you go in a nutshell, essentially. So this now is our finished part. So I had a lot of trouble, believe it or not, getting this part off the damn printer. So I tried lifting it off at first and it was flexing the whole bed. So okay, they've got a little print removal tool. Okay, Well, I ended up trying this from a bunch of different directions, and I'm quite a strong guy. The bond was simply too good. Yeah, you could put this down to temperatures, layer height and such, but it's also got a partial vacuum inside it now because it was really hot, and as it's cooled down, that hollow part is actually suctioned onto the bed. And in the end, I just had to say, stuff it and tear the thing off the bed. But you can see it retained its quality. The thing looks excellent. This is, of course, a single zone lattice wall. And you can also see inside that it actually was able to print the span, the distance where it's unsupported, quite well across the top underside of the part. This is the sort of thing that I think this printer is best for. Okay? At the end of the job, we simply look at our print controls, like so. Now, this part here was printed on another printer, CR10S Pro. This part here was printed on this particular printer, and you can see that Z acceleration line there quite prominently. The acceleration line, as it goes around a corner, has left a sort of slightly rounded off corner on there. Which of them has the better quality? It's kind of hard to see, unfortunately, in these sort of comparison videos between the two, but I would definitely say that the more expensive printer, funny enough, had the better quality. You can also see the base layer height wasn't set perfectly at the time. This was the first print performed on this printer when it was still having extrusion issues versus the CR10 Smart Pro. This here was actually the second print performed on this printer. It's an Elven Tower from Sacros Mundus, I believe it is, and it looks excellent. Printed it as two separate parts. The top was then glued onto the lower half, just a bit of super glue. And this is excellent Eldar, Dark Eldar, High Elf, Dark Elf sort of terrain to put on your tables. Also printed out some of these little ZM tile parts, ZM walls, and although they're in cartoonish colours now, hit them with some filler primer, someone like 3M for example, and a good coat of paint, and these will be indistinguishable from the store-bought particular products, and it was a matter of cents to print these. They use like 50 grams or something of PLA, and it's $24 US for 1 kilo of PLA. So you can print an entire board with just probably 2 rolls, $50 worth of materials. And you can see the quality is excellent. Yes, you can see some slight striation, but keep in mind, this was done with a very low detail setting in the printer. So I think the quality of the actual print is excellent when you take that into account. The colour is a bit trippy though. I actually took the two different ones here. They were printed one after the other with the same rainbow filament. As you can see, the transition is actually pretty cool. So if you were into just using 3D printers for the art of 3D printing, you could do some pretty cool stuff here. Also showing you a bit of scale with a model I printed in the Hellot 1 Plus resin printer, also from Creality. So a little plug for that printer. I'm still ongoing with that. I did a review on it, but I like to keep testing printers after I've reviewed them for a long-term report. So yeah, overall, very happy with the performance of the machine. Will reiterate though, the build quality sensor issue really ground my gears. But apart from that, the printing experience it's actually been really nice. I have had to do far less with this printer than any of my other Creality printers, with the exception of the CR10 Smart Pro, which is another printer I'm reviewing right now, and that printer is twice the cost of this printer. Now, one could question again the price of the printer compared to, say, the lowest end entry model like the Ender 3 Pro. I think it is definitely, you couldn't turn a Pro into this for the same amount of money. You couldn't buy a Pro and upgrade it to the quality of the Ender 3 Max Neo without spending probably $200 more on it. So it's definitely worth it from that standpoint. And the simplicity, if you can do a basic zeroing on it, that BL Touch is going to look after you. It is going to be a very simple printer to use, which is excellent for you if you're a person who's new into 3D printing. That's really good. And so it gets a solid recommendation as a beginner printer. And I need to stress that point, a beginner printer, because there are things it could do better if you're going to be doing advanced levels of 3D printing on it. Now, advanced levels of 3D printing isn't just down to the printer, it's down to the person who's performing the prints. You're going to have to change settings in the slicer, you're going to have to change parts in these printers, modify them, make them better. And this printer has a lot of scope for modification, such as putting a dual gear extruder on, as I mentioned, changing out the build plate, moving away from the carbon glass and putting on, say, a flexible magnetic steel build plate, for example. All viable options. And they're things you're going to have to do if you want to get this thing to perform to its actual maximum capabilities. But straight out of the box, it's a fantastic printer. I think that it's probably head and shoulders above some of its rivals, especially down to the fact that it actually has that BL Touch Pro built in. For the price point, it is very good. Now, can you do better? Potentially. But have I got printers for the same price point that are better? And I would say no. And a very firm no at that. Anyway, that's all from me, Mac with the Outer Circle. Thank you all for watching, and if you have any questions or comments, please post them below. I'll also put up a link to the Creality website if you're interested in purchasing this printer. That'll be provided in the notes underneath the video. So thank you all for watching, and I'll catch you all on the next one.